Previously, we've been dealing with algebraic expressions that only have one unknown. For example, we have this expression 2x plus 3 is equal to 4. We have an expression of 4x plus 1 is equal to 3. All these algebraic expressions just have x as the unknown. So this is an algebraic expression with one term as an unknown, a variable x. So we can easily find the value of x. Even here, we can easily find the value of x. The expression only has one unknown. But now there are algebraic expressions that have more than one unknown, such as this one. Now, when it comes to such algebraic expressions that are having more than one unknown, it becomes tricky for us to find this value of x or to find this value of y just using this one unknown. So now, how do we find the value of x and y? Now, we can only find the value of x and y if a second equation is introduced, and this second equation that is introduced must also be having the unknown x and the unknown y. Now, when this second equation is introduced and now they become two equations, now those two equations are what we call simultaneous equations. So in general, simultaneous equations can be defined as a set of equations having two or more unknown variables. The unknown variables can be in various forms. The unknown variables can be 2, they can be 3. Now, in this series of videos, we shall be dealing with simultaneous equations. Thanks for tuning in. This is Kisembo Academy. Now, the simultaneous equations, like I had earlier said, can be in various forms. We can have simultaneous equations that only have two variables, that is x and y. It means for us to be able to find the value of x and y, we are supposed to solve these two equations simultaneously. We can also have simultaneous equations that are having three variables, x, y, and z. So we have x, y, and z, and there are three equations. So we solve these three equations simultaneously to find the values of x, y, and z. Before we were looking at algebraic expressions with just one variable. For example, if you look at this equation, we have 2x plus 3 is equal to 4. To find the value of x, it means, of course, we are going to shift 3 to go that side. Of course, when we shift 3 to go that side, it becomes here 4 minus 3. We remain with 2x on this side. When we divide both sides by 2 here, we shall end up with our value of x as a half. That is when we are having one variable in the algebraic expression. But what about when we have two? We are having two variables. For example, in this equation, we have x and y. We can't simply easily get the value of x or the value of y unless we introduce a second equation so that we solve the two equations simultaneously. So, in this video, we shall be dealing with simultaneous equations first that are having two variables. Now, there are various methods we can use to solve simultaneous equations that are having two variables, such as these. These are the methods we shall be exploring throughout this series of videos. We shall look at the graphical method, the substitution method, the matrix method, and the elimination method. So in our upcoming videos, we shall explore each and every method stipulated here in detail with illustrative examples. Today we shall get to look at solving simultaneous equations using substitution method. Now, by substitution method, it means just like the word, we are going to substitute. We have two equations. We want to find the value of x and y. What we are going to do is simple. We are going to get one equation and substitute it in another equation. And when we substitute it in another equation, then we are able to find the variables that we are looking for. Let's call this equation 1 and we call this equation 2. So let's choose on equation 2 and we try and see if we can substitute it in equation 1. Now here what we do is that we make one of these the subject of the formula. We can make one of the variables the subject of this formula. Let's say this is x minus y is equal to 2. That is equation 2. So what we do is that we are going to let's choose x. You can choose y if you want, but let's choose x. So if we choose x, we make this the subject of the formula. It means that this value of y is supposed to shift that way. It means that our value of x here is going to become 2 plus y. So when it becomes 2 plus y as our value of x, so we are going to substitute this value of x, this 2 plus y, into the first equation. So we substitute for the value of x at that spot. So it means our equation 1 is going to become, where there is x, we put this expression of y. So we put, it becomes 2 plus y, then plus y is equal to 4. So we go ahead and solve for the value of y. So this becomes 2 plus y, which is 2y, is equal to 4. So we shall end up with 2y giving us, this 2 goes that side, and it becomes 2y is equal to 4 minus 2. So 2y becomes 2. When we divide both sides by 2, this goes with that. We remain with our value of y as 1. So now after getting our value of y as 1, so we go back and substitute this value of 1 into any of these equations. We just choose of any, so that we are able to get the value of x. So let's substitute the value of y in the second equation. So if the value of y is 1, so from the second equation, which is x minus y is equal to 2, we substitute for the value of y, which is 1, in this equation. So if our value of y is 1, we put our value of 1 here, and we get the value of x. So this is going to become x minus y is equal to 2. So it means that substituting for the value of 1 here, we're going to get the value of x, so it means it's going to become x minus 1, our value of y is 1, is equal to 2. And so when this negative 1 crosses and comes this side, we get x is equal to 2 plus 1, and we get our value of x as 3. So it means our answer is that our value of y is 1 and our value of x is 3. We'll do another example. In our second example, it's still a simultaneous equation that requires us to find the values of x and y. We are using substitution method. So we shall choose which one we want to substitute. We can either substitute for the value of x or the value of y in any equation. It depends on what you really want. This is equation 1. This is equation 2. So what we shall do for this case, let us look at equation 1. We make y the subject of the formula. So when we make the y the subject of the formula in equation 1, then we substitute that value of y in the second equation, and then we shall proceed and find the values. So let's get equation 1. Our equation 1 is 2x plus y is equal to 8. When we make y the subject of the formula, this 2x crosses comes this way, so it becomes y is equal to 8 minus 2x. So after making y is the subject of the formula, so you substitute this value of y in the second equation. So where there is y, this 2y, we are going to replace this value of y with this expression 8 minus 2x. So we go to our second equation here. Our second equation is 3x plus 2y is equal to 10. So we substitute for the value of y. So this is going to become 3x plus 2 times y. Our value of y is 8 minus 2x. So it becomes 8 minus 2x, close brackets, is equal to 10. So this becomes 3x plus 2 times 8, we open brackets, 2 times 8 is 16. Then 2 times negative 2, of course positive 2 times negative 2 is negative. So it's going to be negative 4x is equal to 10. So we proceed and get the value of x. So this will become 3x, we collect like terms, 3x minus 4x plus 16 is equal to 10. So 3x minus 4x gives us negative x. This plus 16 is equal to 10. When we are to transfer this 16 to go that side, it becomes negative x is equal to 10 minus 16. Negative x therefore becomes 10 minus 16, which is negative 6. And of course, when we multiply both sides by negative 1 to eliminate this negative, we get our value of x as 6. That will be the value of x. So after getting the value of x, we can now go ahead and find the value of y. How do we get the value of y? We shall get this value of x that we have gotten and just substitute it in any of these equations. You substitute it in any equation you choose and you get the value of y. Let's substitute it in the first equation. So we get our value of x and substitute it in our first equation, which is 2x plus y is equal to 8. So in our first equation, which is 2x plus y is equal to 8, we substitute for the value of x, which is 6, so it becomes 2 times x, which is 6, plus y is equal to 8. So we'll go ahead, 2 times 6 is 12, plus y, which is going to be equal to 8. So definitely this is going to give us y being equal to 8 minus 12, and we will get our value of y as negative 4. So from here we can simply see that our value of x is 6 and our value of y is negative 4. And that is how we find the values of the variables in a simultaneous equation using substitution method. How to solve a simultaneous equation using the elimination method. We are going to illustrate this using a worked example. Right there we're having a simultaneous equations, x plus y is equal to 4 and x minus y is equal to 2. Now by elimination method, just like the word itself says, elimination means that there is a variable we are going to have to first eliminate. So we first eliminate that variable and then we remain with the other variable. Then after getting the value of that other variable we have remained with, then we can also automatically get the other variable we had initially eliminated by substitution. So we'll start working. We have these two equations. So we can choose, what can we eliminate? Can we eliminate x? Should we eliminate y? Now for this case, let us choose. We can choose any, but let's choose x. So we have the equations are x plus y is equal to 4. Then we have x minus y is equal to 2. Those are two equations. Now, eliminating means that we are going to subtract this equation from that equation, this equation from that equation. Now, we're supposed to do it in such a way that when we set this minus that, the variable we are seeking to eliminate should not be existent in our answer here. So it means that in this case, if we are having x and this x is what we want to eliminate, it means it's going to become, we shall subtract the second equation from the first equation. Because in this case, if we subtract x minus x, we shall get 0 here. So since x minus x will be giving us 0 here, it means we will have eliminated x. And if we will have eliminated x, it means we shall be remaining with only y. And if we can only remain with y, then we shall be able to get the value of y. So since x minus x gives us 0, then it means we are going to do it throughout. We are going to subtract this from that. So it means we shall say x minus x is 0. Then this is positive y minus negative y. Now remember, this is positive minus negative y. This is going to be the same as, it's like saying y minus negative y. Of course, this minus turns into plus. So y plus y is equal to 2y. So it means that this minus negative y is positive 2y. That is going to be equal to 4 minus 2 is giving us 2. So of course here we remain with 2y is equal to 2. When we divide both sides by 2 to get the value of y, we get our value of y as 1. Our value of y there is 1. So now after getting our value of y, because we've eliminated x, now we can go back and substitute the value of y in any of these equations so that we are able to get the value of x which we had earlier eliminated. So we get the value of 1 and put it here. In any equation, let's put it in the second one. So x minus y is equal to 2. So if you are to substitute for the value of y here, it becomes x minus y, which is 1, is equal to 2. So definitely our value of x here is going to become 2. This negative 1 crosses, it comes this way, it becomes plus 1 here. And our value of x is going to be 3. So our value of y is 1 and our value of x is 3. And that's how we solve this simultaneous equation using elimination method. Let's do another example. This is our other example, just like in our previous video. we are seeking to eliminate. Now remember, in our previous example, you realize that the coefficient of x here was 1, the coefficient of x here was 1. So it was just easy, you just subtract and you get 0. And you get the answer. But now we are faced with a circumstance whereby the coefficients are not 1, they are different. If you look at this number, the coefficient of x here is 2, the coefficient of x here is 3. If you look at this one, the coefficient of y here is positive 1, and the coefficient of y here is positive 2. Now, we look for what to eliminate. We can eliminate with either x or y, depending on us. So this is how we do it. It's going to become 2x plus y is equal to 8. 3x plus 2y is equal to 10. So we are supposed to eliminate one of them. The elimination is supposed to be in such a way that when you either add this equation to that equation or subtract this minus that, you're supposed to get 0 here for that variable you want to eliminate. If we look at the variable, if we say we want to eliminate x, 2x minus 3x will give us negative x down here. So the x will still be there, we will not have eliminated it. Likewise, if we say y minus 2x, it's going to give us negative y here. So we will not have eliminated y. So it will still have the variables existent. So what do we do? So in a circumstance like this, we look at the coefficients of the variable we want to eliminate, and then we interchange them so that they look the same. Let's decide now that we want to eliminate x. But in eliminating x, if you look at the coefficient of x here, it is 2. The coefficient of x here is 3. Now, how do we eliminate this value of x with these coefficients being different? What we do here is that we are going to interchange the coefficients. We are going to get this coefficient of 3 here and multiply it in the first equation. So it means we are going to get the first equation here and multiply it by 3. We get this 3 multiplied by 3 in this whole equation. Likewise, we are going to get the value of the coefficient of x here, which is 2, and multiply it in the second equation throughout. So we are going to multiply this by 2. In so doing, we shall be able to make the coefficients the same. So what do we come next here and say 3 times 2x, 3 times 2 is 6x, 3 times y is plus 3y, is going to be equal to 3 times 8 is going to be equal to 24. Then we come down here, 2 times 3 is 6x. 2 times 2y, that is positive 4y, is giving us 2 times 10, which is 20. Now if you realize that after our multiplication, when we interchange these coefficients like that, and we multiplied 3 throughout the first equation, and we got these 2 and multiplied it here throughout the second equation, you find that the coefficients of x here are now 6. This one is 6, this one is 6. And if we say 6 minus 6 is going to give us 0. So it means that now it is easier to eliminate x at this point. So we subtract this minus that. So 6x minus 6x is going to give us 0. Then 3y minus 4y is going to give us negative, because 3y minus positive 4y is going to give us negative y, is going to give us 24 minus 20 is going to give us 4. And of course here, negative y is equal to 4. If we multiply both sides by negative 1, to eliminate this negative from the y, we end up with our value of y as negative 4. So our value of y is negative 4. After getting our value of y as negative 4, we shall just go back and substitute this value of y in any of these equations so that we are able to get the value of x. So let's substitute this negative 4 in our first equation. So in our first equation, it's saying 2x plus y is equal to 8. So it's going to become 2x, y is negative 4, so it's going to become minus 4y. mean minus 4 is giving us 8. So this is going to become 2x, giving us 8 plus 4. And this shall give us 12. So 2x is going to be equal to 12. When you divide both sides by 2, we shall get our value of x as by 2 ones by 2, 6. So that is how we solve. We are able to get our value of x as 6 and our value of y as negative 4. So that's how we solve simultaneous equations using elimination method. This marks. Now, using the graphical method to solve the simultaneous equations we are having here, what we do is we are going to draw. We have two equations. These are linear equations in the form of y is equal to mx plus c. So what we do is that we draw this linear equation on a graph. We draw a graph of x plus y is equal to 4. Then we shall draw a graph of x minus y is equal to 2. Then where these two graphs or where these two lines intersect, the values of x and y at that point are the solutions to these equations. So we begin. So we shall first get the points for the x plus y. So we have line, let's draw line x plus y. Line x plus y is equal to 4. So let's get the coordinates. We shall just get two coordinates and connect the two. So looking at line x plus y is equal to 4, we shall say if this is x and this is y. So if x is 0, what is y? If the value of x is 0, it means if we put 0 here, we shall have 0 plus y is equal to 4. So the value of y is equal to 4. So when x is 0, y is 4. What about when y is 0? If we put a 0 here, when y is 0, what is the value of x? Still, when we put the value of y here 0, we shall have x plus 0 is equal to 4. So it means we'll have x being equal to 4. So our value of x will be 4. So it means that we have two coordinates. We have coordinates x comma y, which is 0 comma 4. And also we have 4 comma 0. So we shall connect these two and we have the line. Now this is 4. Line x plus y is equal to 4. Let's look at line x minus y is equal to 2. So for line x minus y is equal to 2, still we shall draw our small table. This is x, this is y. And then we are supposed to find out when x is 0, what is y, and then when y is 0, what is x. So we begin. Now, when x is 0, when we substitute for the value of x here to be 0, what is our value of y? So when x is 0, it becomes 0 minus y is equal to 2. So this is 9 minus y. When that negative goes away, we shall remain with y as negative 2 down here. So likewise, if our value of y is 0 here, what is our value of x? So if we substitute for the value of y, we put here is 0 here. So it's going to become x minus 0 is equal to 2. So our value of x will be 2. So when y is 0, our value of x will be 2. So we shall come up with coordinates 0, comma negative 2 and 2, comma 0. So we shall plot this. We shall plot to draw line x plus y is equal to 4 on our grid. Then we shall also plot this line to get that. And where those two meet is the solution. So looking at our grid here, we have a grid. Line x plus y is equal to 4, we have 0, comma 4. So it is 0, comma 4. That is our first, it's right there. This is 0, comma 4. Then we also have 4, comma 0. And then we have 4, comma 0 right here. So from here, we shall connect these two. So this is our line y, x plus y is equal to 4. So that is our line x plus y is equal to 4. We have finished with this line. So we draw this other line, x minus y is equal to 2. So x minus y is equal to 2 has coordinates 0, comma, negative 2. So we look for coordinate of 0, comma, negative 2. It is right here down. 0, comma, negative 2 is down here. And then we have coordinate 2, comma, 0. 2, comma, 0 is right there. And of course, when we draw this, this is our line, x minus y is equal to 2. So this line and this line, they meet at that point. They are meeting at point 3, comma, 1. Because this is 3 and that is 1. So at that point where they meet is where we are having the solution to that equation. It means that our value of x here is 3. So meaning our value of x is 3. And our value of y is 1. So our value of y is 1 for this simultaneous equation. And this is how we solve simultaneous equations using graphical method. We'll illustrate this further with another example. We have that other pair of simultaneous equations. We are supposed to solve it using graphical method. So solving this simultaneous equation using graphical method is simple. We are simply going to draw that line, draw this line. Where those two lines intersect is the solution to the simultaneous equation. So we begin with the first line. Line 6y is equal to 3x plus 18. Again, we shall draw our table here. This is our value of x and our value of y. And we shall seek to find when x is 0, what is y? And then when y is 0, what is x? So we shall do some side work here. When our value of x is 0, if you look at this equation, when our value of x is 0, what is our value of y? This is our question. So doing some side work here, when our value of x is 0, we have 6y is equal to 3x. When our value of x is 0, so if this is 0, 0 times 3 is 0, so it becomes 0 plus 18. So remain here with 18. When you divide both sides by 6, we get our value of y as 18 divided by 6 is 3. So when our value of x is 0, our value of y is 3. So likewise, if our value of y is 0, what is our value of x? So likewise, when our value of y is 0, we substitute. 6 times 0 is 0. So we shall have here 0 is equal to 3x plus 18. We are substituting. So it means that when this comes this way, it becomes 3x is equal to, when this 18 comes this way, it becomes negative 18. When you divide both sides by 3, this 3 goes with that, these 3 ones. 18 divided by 3 will get 6, negative 6. So this becomes negative 6 is equal to x. So it means that when our value of y is 0, our value of x in this equation is going to be negative 6. So it means that our coordinates here are 0, 3 and negative 6, 0. So that is this line. So let's look at the next line. Line this, negative 2x minus 2. Still we shall draw our table, x, y. When x is 0, what is y? When y is 0, what is x? So let's start. When our value of x is 0, what is y? So this is line, this is equal to y. So when our value of x is 0, when we put a 0 there, this is 0 times negative 2, this term dies. So it means our value of y is going to be negative 2. Likewise, if our value of y is 0, if we put a value, our value of y here, if it is 0, our value of x is going to become, so our coordinates is going to become negative 1, 0. Because when our value of x here is 0, when our value of y is 0, this negative 2 will cross that side. When you divide both sides by negative 2, we shall be having a value of x as -1. So we have 2. So we go ahead and plot them. So on our grid, we have 0, 3. So 0, 3 is right there. This is 0, 3. Then we have -6, 0. Our -6, 0 is right here. That is -6, 0. And so we shall draw that line. So this is line 6y is equal to 3x plus 18. So let's go ahead and draw the other line, which is 0, -2. So we'll begin with 0, -2, which is down here. 0, -2 is right there, which is 0, -2. Then we have -1, 0. -1, 0 is right there. So when we this is -1. So when we connect these 2 points, this is what we have. So this is line y is equal to -2 x minus 2. That's the line. So these two meet at this point, and what's the coordinates of those points? The coordinate of that point is -2, 2. Since now these two lines of these two equations, when you draw them, they meet at that point of -2, 2, it means that as far as this simultaneous equation is concerned, the value of x here is -2 and the value of y here is 2, and that's the solution to the variables in this simultaneous equation. How to solve a simultaneous equation using matrix method? It's Kisembo Academy, and thanks for tuning in. There are very many other ways of solving simultaneous equations. We can solve simultaneous equations using elimination method, we can use substitution method, we can use graphical method, but this tutorial will concentrate on just one of the methods, and that is the matrix method of solving simultaneous equations. We'll illustrate using an example. We have these two simultaneous equations, 2x plus 3y is equal to 4, and also we have x plus 2y is equal to 3. These are two simultaneous equations that require to be solved using matrix method. So to begin it off with, we need to first of all extract the matrix we are going to deal with. And we extract this matrix by just extracting the coefficients of the unknowns. The coefficient of x here is 2, so we extract 2. The coefficient of y here is 3, so we get the 3. The coefficient of x here is 1, so it is the 1 there. And then the coefficient of y here is 2, and that's the 2. So we end up with our matrix as 2, 3, 1, 2. So this is the matrix. We multiply this matrix by the unknowns. The unknowns in this case here is x and y. So we follow that order, x and y, because the first term here is x and the next is y. Now if it is the reverse, if it was 2y plus 3x, or if it was y plus 2x, then it means that the order of our unknowns here would be y and x. The order of this matrix, the way we present them, is dependent on which comes first here. Here it is x that comes first, so it is x coming here first, then y comes next, so y next. So this matrix multiplied by xy is supposed to give us 4, 3, and that is the 4, 3. So now we are going to deal with this to find the value of x and y. So for us to be able to find the value of x and y, it means that we need to eliminate this matrix from this side so that it goes this way. We need to remain only with the unknowns here. So now for us to be able to eliminate this matrix, it means that we're supposed to multiply it by its inverse. When we multiply this matrix here by its inverse, it means that we are going to remain with nothing here, or we are going to remain with an identity matrix here, so that we're able to remain with x and y on only this side and the rest is the other side. So it means that we are going to find the inverse of this matrix. When we get the inverse of this matrix, we multiply it on both sides. We multiply it on this side and that side, and then afterwards we'll progress and we'll remain with xy on just one side of the equation. So we begin by finding the inverse of this matrix. In our previous videos, we explored in detail on how to find the inverse of the matrix. So we all know that finding the inverse of the matrix is equal to 1 over determinant times the adjoint. So we first get the determinant of this matrix by saying the major diagonal, which is 2 times 2, minus the minor diagonal, which is 3 times 1, to get our determinant as 1. After getting our determinant as 1, we find the adjoint of this matrix. The adjoint of this matrix we get by interchanging the numbers in the main diagonal, which is 2, with the 2's interchange. Then in the minor diagonal, we simply multiply the numbers by -1. 1 times -1 is -1. 3 times -1 is -3. So after getting the determinant of the matrix and the adjoint of the matrix, then we can substitute it in here so that we are able to get the inverse of the matrix. And it is this inverse that we are going to multiply here on both sides. And this is what is happening in our next step. In our next step, we are going to multiply the inverse of the matrix, which is 1 over determinant times adjoint, times the original matrix, which is that one, this one, times xy, which is that, is equal to 1, the inverse of the matrix, which is 1 over determinant times adjoint, which we are going to multiply, times 4 over 3, which is that, 43. So it's the substitution going on in the next step. So 1 over determinant is 1 over 1. 1 is the determinant times the adjoint, which is this one, which we already got here, times this, times that, is equal to 1 over determinant, which is 1 over 1, times our adjoint, which we already got as 2, -3, -1, 2, times 4, 3. Then the rest is math. So we multiply this by that. And when we multiply a matrix by its inverse, we are supposed to get an identity matrix. So as we are multiplying here, you're supposed to make sure that the final answer you're getting is an identity matrix, 1, 0, 0, 1. Now, if you multiply these two, and what you're getting here is not an identity matrix, then it's supposed to show that there is something wrong with your calculation here. So we get that, multiply it here, we do the same on the other side. And so, of course, the multiplication, it's row by column, 2 times 2 plus -3 times 1, then this row times that column to get this, 2 times 3 plus -3 times 2, which is that. Then we have this -1 times 2 plus 2 times 1. Then we have -1 times 3 plus 2 times 2, which is that. So when we compute all this, we shall end up with the identity matrix times xy. On this side of the equation, it's simply going to be matrix multiplication. This row times that column, then this row times that column. 2 times 4, which is that, plus -3 times 3, which is that. Then we have -1 times 4, which is that, plus 2 times 3, which is that. And then we compute that and we end up with -1 and 2. So now, of course, when we multiply an identity matrix by any matrix, this gives us the same. This times xy gives us xy is equal to -1, 2. So it means our value of x is -1 and our value of y is +2. And so this is how we solve a simultaneous equation using matrix method. We'll do one more example. We have a number 2p minus q is equal to 8, 4p minus 3q is equal to 14. We are required to find the values of P and Q in that simultaneous equation. So we are going to extract our matrix by extracting the coefficients of those unknowns. The coefficient of the unknown here is 2, the coefficient here is 4, the coefficient here is -1, the coefficient here is -3. So it means that our matrix here is going to be negative, it's going to be 2, then that is 4, then this is -1, then this is -3. Multiply that by the order of the unknowns, it's P coming first, then Q. So it's going to be P, Q, that is supposed to give us 8, 14, 8, and 14. Then after that, then we go ahead and find the inverse of this matrix. When we get the inverse of this matrix, we multiply it on both sides. So the inverse of this matrix is going to be, first get the determinant of the matrix, which is 2 times -3 minus 4 times -1. We end up with -6 minus -4. It's going to give us -6 plus 4, giving us -2. So this is our determinant. So we go ahead and find the adjoint of this same matrix. So the adjoint is simply going to become, we interchange these numbers in the main diagonal, which is, so here we have -3, and this 2 comes down here. Then in this diagonal we multiply by -1. 4 times -1 is -4. -1 times -1 is 1. So we go ahead and, so it means that our inverse, the inverse of the matrix is going to be 1 over determinant, which is -2, times the adjoint, which is -3, -4, 1, and 2. So after getting our inverse, so we are supposed to multiply the inverse on this side of the equation and that side. So bringing this back, it's going to become 2, 4, -1, -3 times PQ is supposed to be equal to 8, 14. So we are supposed to multiply this inverse on both sides of this. So multiplying that is going to give us -1/2 into -3, -4, 1, 2 times that is supposed to give us 1 over 2, this is negative, into -3, 4, 1, 2, like that. And then the rest is matrix multiplication, and we get our answer.